So 75 rational exponents and radicals. So what's a radical, you ask? Because I know you're about to. That's a radical, right? So like square root sign is a radical. Now, we can write anything in this little, I call it the elbow part of the radical. In this case, we have a 3, right? But this one means the exact same thing as that one. So a square root is the same thing as a second root. It's important because we're going to be dealing with fraction exponents, and sometimes you need the little 2 in the elbow, just so you know that. But before we do this problem, we're going to make a chart. So when we make the chart, leave yourself like 10 spaces on your paper. See, this thing is like hard to breathe out of too. If I suddenly pass out, you'll revive me, I hope. Okay, so we're making this chart. We have x, then x squared, x cubed, x to the 4th, and x to the 5th. So I'm not going to write 1 because that's stupid. 1 times 1 times 1 is always 1, so just know that. So we'll start with 2. If I square 2, 2 times 2 is 4. If I multiply that 4 by 2, I get 8. The 8 by 2, I get 16. 16 by 2, I get 32. Oh, so by the way, I told you last night would be the first night that it would take points off if you didn't have the page number, problems, your name, and the class period. Right, so if it's Charlotte Coleman, she'd write Charlotte Coleman, she'd write tonight's homework is 450, 11 through 33 odd, period 4. So if you're missing all 3, your homework starts at a 7. You can't ever get those points back. That's what I told you yesterday. I keep to my word. So if you're missing one of those 3 things, you just miss 1 point per whatever you're missing. So strangely, many of you will write the problem numbers, but not the page number, which is just totally bizarre to me. I don't know why you would do that, but so make sure you have your name, the page number with problems, and period 4 at the top of every homework assignment. So from here on out, unless I forget, so I graded like half your homeworks, forgot, and I went back and regraded them so I could take points off, because I'm that kind of guy, just so you know. So check it out. Make sure you look at grades in Schoology, because I make comments. Also write stuff on your homework if you did problems wrong. That'll help you to understand the math. So it's good to go back and look at your homework. All right, next is 3. 3 squared is 9. 9 times 3, 27. 27 times 3, 81. 81 times 3, 243. We'll talk about how to use this chart in a sec. 4 squared, 16 times 4, 64. 64 times 4, 256. 256 times 4, don't quote me. I think it's 1,024, but I'm going to check. So what was it doing? I was doing 4 to the 5th power. Okay, 1,024. Now it'll be 5. 5 squared, 25. 5 quarters, I have $1.25. 125 times 5, 625. 625 times 5. I don't want to do it in my head. You can see why. 3,125. Now the book will rarely make you use like the bigger numbers to the 5th power, but you'll just know what they are. We'll stop with 6. 6, 36. 36 times 6, 216. Let's make sure. Yeah. So that times 6. 1,296 times 6. 7776. So 1296. Okay, so here's how I use this chart, right? If I want to know what 2 to the 5th power is, you just look right there. Okay, if I want to know what the 4th root of 81 is, then I'm going to look at 81. I'm going to go back here to the 3. 4th root of 81 is 3. Okay? And we'll talk about this chart frequently as we start going through the lesson, but I'll do a couple more. So if I want to know what the cube root, right, I look for x cubed up here. So if I'm going the opposite direction, cube root of 216 is 6, right? 6 to the 3rd power is 216, 6 to the 4th power, 1296. So we're going to kind of go back and forth with the thing to look at it like that. Hang on 1 second. IT tries to log you off too quickly. Okay, I'm just going to take those off because we'll be looking at this chart again. So if we go back here, what is the cube root of 125? Let's go to the chart. Cube root of 125 is 5. Show me at home too. Don't be lame. Good job. Okay. So cube root of 125. The big highlight equal sign is 5. So they'll get much harder, trust me. But we'll start easy. 4 through 16, look at your chart and tell me, show me with your hands. As soon as I call your name, put your hand down. Cole, good. I can't even tell, oh, that was Volpe. Volpe's hiding her makeup for the show. Everyone's good on there. Put your hands down. Everyone's good in person. Except I can't tell what the hell Maddie's doing. 4 through to 16.
Wait, we're supposed to put the number up? Oh, I thought we were supposed to raise our hands.
Yeah.
Okay, so I wasn't it.
That's where you give your peace
That's what I
sign.
was gonna do.
Yeah, that's what you're gonna do. Maddie was like doing one of these numbers, you know, like.
At
"Hey,
first she was doing 2, and then she just...
Then she died. That's it. Okay. So 4 through to 16 is 2.
Whoa, that's a big 2.
Big tail. Cube root of 27. Now I can't see anyone at home because they all went blank. We've had weird Wi-Fi going on today. Could you guys tell in your classroom at all? Weird Wi-Fi? Because the pictures keep going in and out on this thing, which is weird. What's this answer? Show me. You're good. At home? I can't see, so don't worry about it. You have trouble going like that? Because that finger doesn't go down? Go like that. Yeah, that thing do it too. Oh, nice. Yeah, you can do the rocker one too. Alright. Means rock on. So, cube root of 27, or what did you say?
Spider-Man.
I thought you said, or spank me. I was like, well, we don't have that kind of class at Monarch High School. That was pretty funny though. Like, oh geez. Alright, 5th root of 32. I can't see any of you. You can write it in the chat. How about that? Hopefully I'll be able to see you again soon.
I said it.
Yes, you did. Good job. 5th root of 32. So if we go back to the chart here, we want to do 5th root of 32. You look up at the x to the 5th right there. Find 32 and go back to the beginning. 5th root of 32 is 2. Excellent. Let me just kick that off there. Go back. Now that comment I made about what I thought you said will be on the video too, which is always amusing. Okay, cube root of 64. Don't doubt yourself, Austin. You're right. Yeah, you're good. You're good. Yes, good. Answer in the chat. I was thinking the wrong thing in my head. That's why I looked at you like you were crazy.
Well, I already know you were crazy.
And me too.
4.
All good. 4. Good job for those of you that answered in the chat. Square root of 36. Answer in the chat. Or here. Isn't that chart handy? This just makes it so much easier. That was awesome. Lauren just answered with pterodactyl, or T-Rex arms. She was like, 6. Yes, that was excellent. 6 should be the answer. Some of you answered. Good job. Seems really easy now, right? Oh, just wait. So some people like this kind of crap. I personally don't. I like numeric examples. They make more sense to me than all the letters. I'm just like, I don't even know what the hell's going on. I can make it a little bit bigger if you can't see it as well. Make it a lot bigger. So, yeah, I look at that and I'm like, that is zero help to me. But if that works for your brain, then do it. That's great.
Is that supposed to make sense to us?
Yes. Here's how it can make sense because I can teach. Yay.
Oh.
So let's say, so these are 2 separate things, so we'll talk about them separately as well. I'll just see my line down here. So let's say I have 2 to the, no, let's not do that. Let's say I have 32 to the 1/5 power. Ooh. Wow, that was loud. So that turns into this. So those 2 expressions mean the same exact thing. So here's how I know where this 5 goes, that it goes in the elbow. This 1 goes underneath, and the 5 goes in the elbow of the radical. So this is what I'm calling the elbow right there. So I envision this part of the radical as an arrow that points down. So the denominator goes in the elbow because it points down, right? And then the numerator goes underneath, or it can go outside, either one. We'll talk about that more later, not as important right now. So this one right here, let's say we have,
A little bit, okay.
I gotta think, let me just, we'll make one up, let's say 16. We'll say we have 16 to the 3 halves power. So that'll work out to a whole number. Okay? So the 2 goes in the elbow of the radical, just like this n did, right? So the n from the denominator goes in the corner of the radical, and they're showing you here this m can either go underneath the radical or outside of the parentheses, so outside of the whole thing. So when we do that over here, it's like the second root, so that q goes into the elbow, right? Denominator points down, and then the 16 is underneath. So I'm going to do it like this, because I know I can do the square root of 16 in my head. So I'm going to put this whole thing in parentheses. I'm going to write the 3 outside.
Oh, wait, okay.
So what's the square root of 16? Show me. I can see your pictures now at home. Show me square root of 16. It's good, Cole. I got you. You should have 4 fingers up. Square root of 16 is 4. Use your chart, right, if you don't know them by heart. And just so you know, it's a good idea to memorize like x and x squared from 1 to like 12.
Wait, why is it on the outside of parentheses?
Remember, it can be either underneath or outside. So the reason I chose to write this 3 outside of the parentheses is because I'd much rather take the square root of 16 than cube 16. Because then I have to multiply 16 times 16 times 16, which is a hassle. I say no. Because then, once I simplify square root of 16 to 4, 4 to the 3rd power is 64. So moral of the story, what's in the denominator of the fraction exponent goes into the elbow of the radical, and then I can write this 3 either underneath the radical or outside. So that's still following the order of operations with exponents, just gets a little funky. All right, we good on that? Okay, so we're going to write this 12a to the 2/3 power. We're going to write that in radical form. So just like when we were moving stuff upstairs, downstairs, the whole should I stay or should I go concept, you still got to treat the 12 and the 8 of the 2/3 power as totally separate, right? So it's technically 12 to the 1st power. So the 12 has nothing to do with the radical. I just write that in front. And now I'm going to write the radical, right? The denominator goes in the elbow. The a goes underneath, and the square could either go here, or you could put the whole radical in parentheses and write it outside. So I just taught you that. I'm going to give you one more example, and then I'm going to have you do one at home, and like half of you will forget this rule. I say that as both an insult and a challenge. Okay? So take it as a challenge, not an insult. That would be my recommendation. So if I look at this, I just did 64 to the 4/5 power in the calculator to see if I got a whole number or not. So if I get a nasty decimal like that, it really depends, like when I give you a quiz, if they give you this decimal or not. They probably won't. They just want you to switch from exponential, right? We have an exponent 4/5 to radical form. So I'm going to write this bigger so those that are in person can see it better. So 64a to the 4/5 power. That's different than the previous problem because the 64 is inside of the parentheses. Okay? So the 5 goes in the elbow of the radical. And then technically, I think the book answers will have it like this. And I would take a half point off the book answer. Like, I'm more hardcore than the book answers. This is not fully simplified. Why is it not fully simplified, you ask? Because I still have to distribute that exponent into the parentheses for it to be fully simplified. I show you this answer, because I bet you the book answer, or when I give you a quiz on this, that's what they'll have. But for me, I want you to write it like this. 5th root. And you don't have to do 64 to the 4th power. I'll show you how big a number that is. But that's, you know, even technically that's not the most simplified because we didn't do 64 to the 4th. But let's see how big that number is because that'll be fun. Was somebody in here, or maybe you're in person, downloaded a graphing calculator app on their phone?
No, I'm getting a graphing calculator.
Did somebody at home do it? Because I asked last period and they said no. Cole, you have one? Is that a graphing calculator? It's hard to tell because it's like the size of a thimble. Yeah, no, that. Oh yeah, that's a good one. Is it Casio, that thing, or Texas Instruments? Casio? Smash it with a hammer and buy a Texas Instrument. Okay. I never said that. So 64 to the 4th power, you can hit the little caret thing below clear, right at 4, and then you get that gigantic number. So if you get a number that big, don't worry about it, just write 64 to the 4th power, okay? Somebody had that. So I know, once I figure out who it is, or maybe I'll just research it since nobody's answering, I'll find you the good graphing calculator app for your phone, which you could use this school year, but if we come back in person next school year, God, I hope so, you won't be able to use your phone during a test, but at least it'll get you through this year. So yeah, we're good. All right, so now we're going to radical form. So try this one at home. I'll check in person, and then I'll write the answer up in a second. Was it you, Anna? Did you have to grab some calculator out? No? Volpe, was it you? Because Shay said, I think it was Anna, and we have two Annas. The other one? Okay.
I'm pretty sure.
All right, so once I come around, if you guys can point to where it is, it just makes it easier. Did you do it yet? Okay. I was wondering if you just had a placing moment. So you have 2 6s there? Yes, Anna?
Sorry.
One should be the bottom. Are you done? Oh, you're still working. Okay. Excellent. Excellent. It was nice Vanna White was too. She was like, there we go. It's right here. Yes, there you go. You good? You get it? Good. So at home, you should have got this. Or you could have got this.
After the lesson, are we gonna have a math break?
Heck yeah. Like my chin is practically dripping sweat when I
Yeah,
start
there's
putting
a
it.
circle, like a circle outline
You
of
can
your,
tell.
of your rubber thing.
Yeah.
Well, like, I don't know if it's condensation or the rubber thing, but you can see it.
It looks extra cool, I know. My stepkid was making fun of me for this thing. It was funny. Harry, what's your question?
How do you know whether the numerator is like outside of parentheses or like inside?
Depends on the problem. Either one is correct. We'll do some problems where I'll show you why it's better to do it one way versus the other.
It's just easier.
Yeah, it'll make more sense once we have that. Okay, try this one. I'm going to trick at least half of you. Austin thought he was done, now he's a little frightened.
I think I might
I
have
can,
it. No one.
I can hardly wait to check. It's going to be awesome.
But can I
Yes.
do this one?
How? Yeah, just wait. You could say it out loud. Good job. I didn't.
Okay.
Everyone in person is on it. Oh, except Lauren. So close. I jinxed it totally, square point. Good job. Aw. I'm going to make one little face, Lauren, and then you're going to do it correctly. Oh, she just her mind went. All right, Volpe, what you got? You're going to try to do it, I think. You're going to try to do it?
Yeah, 5 outside the radical formula 3 in the
Elba.
Can you draw the
Do you want me to write what you're saying?
what? 5 outside of the square root, and then put a theory inside that little thing, but X is versus just X.
X is the first, which is just X. So in the book, they definitely won't write the little one right here. Right? I like to write it just because it gets confusing if you don't. But you could either have that answer for me, or that answer, I wouldn't take points off for either. Okay? Pretty good. So I was like, the reason I do these is to see if I get a whole number here or not. So I don't. So don't worry about the 54 part. So the difference is, now the number part is in the parentheses, so the number part has to go under the radical. Okay? So we have the 3 goes in the elbow, 54y goes underneath. It still has to be in parentheses, so if you don't write those parentheses, I'll take points off. Squared like that. And you don't have to square 54 because it's a big number, who cares?
Wait, whoa, what? Wasn't the 54? Wait, not because it's in parentheses.
Charlotte's talking out loud. She's getting it. It's all good. Right? It's actually good to talk out loud. You can do it at home so you don't feel like a knucklehead. Charlotte doesn't care. I wouldn't care either. I just talk it out loud. Let's see how big 54 squared is. So it's not that big, but bet you the book answer will look like this. You could also write it like this. The reason I write all of these options is because I have no idea what the multiple choice answers are going to look like. Right? Or you could write it like this. 54 squared was 2916.
Parentheses around the whole thing, not the whole thing, but yeah, around the whole thing, not the whole thing.
The only place you would have to have the parentheses is right there.
And then, but couldn't you also put it around the radical thing?
Yeah, so you could have it like this as well.
Yeah.
Like that? Yeah. I bet you the book answer will be this first one. That'd be my guess. This is the best answer right here, but, you know. Check your solutions, because it gets confusing with these things. Now we're going the opposite direction. Okay, from radical to exponential. So this is where I think it's particularly helpful for that down arrow kind of concept with the envelope, because that tells you the 5 goes in the denominator. So, is it b to the 3/5 or 5/3?
3/5.
3/5. Right, so radical form has a little square root thingy. Exponential form has a fraction in the exponent or a whole number, it could be either. Okay, you're going to try this one on your own? This word simplify means you should take the cube root of 27.
Is 27 B supposed to be in parentheses?
Nope. That's the perfect question to ask right there. So the cube root only applies to the 27, right? So you can take that and get a whole number, and then it'll be d. So you could think of this problem like this. Right? And just do them separate. Like that might be easier for you guys to think about. Because what's the cube root of 27? Show me at home. Look at your chart, folks. Come on. You got it. Cube root of 27. Good. Good. Yeah. Excellent. Right, cube root of 27 is 3. And then is it d to the 5/3 or 3/5? 5/3. You guys can unmute and answer those questions too if you want, right?
I don't get how that happens.
Okay, hold on. Let's just do it again, the whole thing. Sometimes it helps to see the similar problem again. Do you want me to divide it out like that or keep them together? Like whatever way makes keep it together? Okay. So if we do, I started wrong. We're going to go 27. So technically it's 27 to the first power, right? So that makes it a little weird to do it together, but we can still do it. So I'm going to say 27 to the 1/3 power. And then d, right, arrow points down, so the 3 goes in the denominator, the 5 goes in the numerator.
Okay, I was thinking about that, but.
Yeah, that's why I think it's easier if you write them separate. So instead of doing that, write it like that, cube root of 27.
You have to like solve it.
Yeah, because you have to solve the cube root of 27, that's why. Now if it were cube root of 28, you just leave it as 28 to the 1/3 power, because it doesn't work out to be a whole number. Here, I have to finish it. You good? Alright, let's try another. I'm going to rewrite it because I don't like when they use S's. X to the 2/3 or 3/2? 2/3 or 3/2? 2/3. right? Easy, easy, easy. Okay, try that one. Try it at home. They're kind of a pain in the neck to write in the chat, so don't. I guess I could make you, but, whatever. I'll write it up. When you're done in person, just put your hand up and I'll shake. Yep. That's a good noise.
Oh, wait, no, I did it
Oh my
wrong.
God!
I did it
What
wrong.
happened?
Wait.
Yes.
Okay, I fixed it.
You did it right again. I just wanted to pause to freak you out. Did it work?
Yes.
Yeah, good.
I was like,
What? I can't see those numbers, sorry, I didn't bring my glasses. What's up top? Yeah, good job.
I fixed it. I actually put the 3 on top.
I know what you did. Down arrow, right? That's the money strategy right there. It just makes it so much easier.
But whatever.
Give me thumbs up if you got that at home. Yeah. Excellent. Oh my God. What goes in the elbow? Show me at home. What numbers implied that they didn't write?
1, 4, and 2. Wow.
Try one more of those. One more finger. 2 of them, yeah. So you can write that little 2 in there. They do that to mess with your head, right? The infamous they. And the 4 and the y are in parentheses, so that 5/2 applies to both of them. So the book answer is probably going to look like this because the book is stupid. Right? That's not good. You got to distribute that crap, right? Because we can do square root of 4. So remember how we talked about the difference between this one? Isn't that problem easier than the equivalent expression?
I got that first one.
Because I don't want to do 4 to the 5th power. That's annoying. But I can do square root of 4 is 2. 2 times 2 times 2 times 2 times 2, 32. Right? So you can go 4 to the 5/2 power, and you get 32. Right? So this way is easier on that problem than this way. So I just want to show you this way on the calculator too. So we go 4 to the 5th power, which is that big number, 1024. But we can take the square root of that. So I hit second x squared in the calculator, and then second negative, which gives me, this means that I'll take this answer, 1024, and plug it in there, and you still get 32. But to save yourself from doing the square root of 1024, do it this way. It's way easier. Right? So if you end up with a reasonable number, do it. If you end up with like that giant number we did a long time ago, don't, because that's known. So you get 32y to the 5/2 power.
Oh, great, huh?
What happened?
Oh,
You
you
can still 5/2 there.
Because this 5/2 has to apply to both the 4 and the y. Because it's in parentheses, that's why.
Ah.
Okay? So it's a difference between the parentheses or not. And I actually wanted to talk about that with, not that one, not that one. There's one, or maybe it's ahead in the lesson. Not that one. Yeah. I'll make one up that'll work. Can't remember which one I was talking about last period. Come on. Okay. 4 through 256, is that in your chart?
Yeah, we have a factor.
256?
Yeah.
I feel like there was something weird about this one.
No, that's in the chart.
Okay, so the 4 through 256. Yeah, that works. So the 4 through to 256, you look at your chart, find 256, double check that you have the correct exponent, right? Because that's how they'll mess with your head a little bit. 4 through to 256 is 4, okay?
I think I solved it.
I hope so.
I hope so as well.
So going back here, 4 through to 256 is 4. Now we have 8, or a to the 8 fourth power,
That's all that happened.
which is the same thing as 4a squared. Okay, so if you can either reduce this fraction or just straight up divide it and get a whole number, always reduce or divide if you can. Alright, question.
Is that 2, or is that turned to squared because 8 fourths is 2?
8 divided by 4 is 2, exactly.
Okay, what if it was like 12?
So if it were this totally related but unrelated kind of problem, that would be 4a cubed, yeah,
Okay, thank you.
right? So just to keep set right alive, just so you can see other weird examples that might happen. Let's say we have 4a to the 12h power, then you have to reduce that fraction. So I'll show you, if you have a graphing calculator, how to do it. I think it was Shay has a graphing calculator. Does anybody else have one? You guys? No?
On in the problem.
Look for graphing calculator app on your phone and try to download mine because it'll be super handy for you. But in the graphing calculator, I can do 12 divided by 8. It'll give me a decimal. That's fine. I just hit math, enter, enter, and I'll change that decimal into a fraction. So what is 12 over 8 reduced? 3 over 2. 3 2. 4a to the 3 2. I like it. Okay. Now, if you have to go old school with that reducing of the fraction, you would divide top and bottom by 4, and that's what you get. Okay? Yeah, yours can do that, Cole, until, like, if I have you in Algebra 2, I literally will not help you with that thing. Because we do linear, quadratic, cubic, and quartic regressions, and it's a nightmare on those things. The ones that I have, totally fine, but the one Cole has, the Casio, not cool. It doesn't work. Okay, so remember my method of story problems, which I shouldn't teach you, but, I like doing things the easiest possible way. So literally, when I look at the story problem, I don't read a single word, to be perfectly honest. I see an equation, I see a number, I guess that number goes in for the m. Okay? Literally, I haven't read a single word. Now I read the problem and see if I'm correct. So you can estimate, here, let me get that out of the way, that's just easier to read. So you can estimate the metabolic rate of living organisms based on body mass using Kleiber's law. The formula, blah, blah, relates metabolic rate, R, measured in calories per day, to body mass, M, measured in kilograms. So the M is kilograms. The M does go in for that M. So you know metabolism, right? That's what they're talking about. Most of you teenagers have high metabolism. It's just part of your body developing. And you burn off calories quickly. That's why you can eat Chick-fil-A like 70 times a week and not get, you don't weigh like 1,000 pounds, right? Chick-fil-A I like to call sodium sandwiches. They're damn good, right? But they are so bad for you, it's disgusting. Don't eat them all the time, you'll have a heart attack. But we're going to plug this thing in. So we get 73.3. Then we do the fourth root of 18 to the third power. Okay, and we can plug, so I'm going to rewrite this exponentially because it's easier to plug into the calculator. So it's 73.3 times, is it 18 to the 3/4 or 4/3? 3/4. You have a question though?
No,
Oh,
sorry.
you're good.
That is it.
So 18 to the 3/4 power, which I did below here off the screen, is that beautiful number, 8.7388, 5.891. Then all I have to do is multiply it by 73.3, and we get 640.56 rounded to hundredths calories. So this whole thing equals 640.56 calories. So that's how much your dog can eat. What the hell does that mean? What is the metabolic rate of a dog with a body mass? Oh, so that's how many calories your dog would burn to maintain its weight. Anybody have an Apple Watch and set a calorie goal? Anybody in here? No? Anybody at home? Apple Watch? Do you set your calorie goal? Nobody? You should get one. They're good.
It doesn't like measure your calorie intake? How?
Heart rate, and then it also figures out, like, I hit my little exercise thing, and there are all these different kinds of exercise, like pool swim, outdoor swim, walk, treadmill, bike, anything, elliptical, Stairmaster, it's got all that crap
I
in there.
love Stairmaster.
Yeah, I got one at home, I do too, yeah.
Becky, I mean, that's
Yeah. That is way too much information, that's all good. All right, so your homework, we're going to take a math break, so just join us outside.
Okay.
So that'd be helpful, huh? One sec. Former student who just figured out she was taller than me. She's very excited. Okay, so your homework is page, I think it's 450. Grab my glasses. So on top of your homework, you're writing this. Okay, we're going to go take a math break. You guys can start working on that. There's no quiz today. We're going to every other section, second semester, all right? That's cool if you need to go, Kason, no big deal. All right, let's go take a math break. Let me get rid of this. I don't like that.
Don't send me the link.
Yeah, I know. It's just like my chin was like dripping with sweat.
Yeah.
It's just nasty.
I probably like hit the ground with like break.
All right, I'll lock up so you don't have to worry about your stare. Follow me, she knows.